All right, let's try some problems. Find the sample variance and standard deviation for the following sample: 17, 40, 24, 18, and 16. So what we need to do is calculate the mean of the sample. So the mean is going to be equal to adding them up: 17 plus 40 plus 24 plus 18 plus 16, and dividing by 1, 2, 3, 4, 5, dividing by 5. So the mean is going to equal 17 plus 40 plus 24 plus 18 plus 16. So it's 115 divided by 5. So I take that 115 divided by 5, and I get 23. So the mean is equal to 23. The next thing I want to do, I'm looking at the formula here. This is the mean. That's what I just calculated. I got to take each value and subtract the mean. So I'm going to go 17 minus 23, 40 minus 23, 24 minus 23, 18 minus 23, and 16 minus 23. So I do 17 minus 23, and I get a -6. The next one I do 40 minus 23, I get a 17. 24 minus 23 is going to be a 1. I do 18 minus 23, I get a -5. And then finally I do 16 minus 23, and I get a -7. All right, that takes care of this section here. Now I have to square it. So I'm going to go -6 squared, 17 squared, 1 squared, -5 squared, and -7 squared. So this is -6 times -6. So on your calculator, you have to do parentheses on that. Make sure you put parentheses. -6 squared is 36. 17 squared is 289. 1 squared is 1. -5 squared is 25. And 7 times 7 is 49. The next thing I need to do is add that all up. So I'm going to add the summation symbol at the bottom, add up all the numbers. So I go 36 plus 289 plus 1 plus 25 plus 49, and I get 400. And to get the variance, I'm going to take 400 and divide it by n minus 1. So again, there's 5 numbers. So 5 minus 1. So it's going to be 400 divided by 4, which is 100. So the variance is equal to 100. Standard deviation is the square root of 100. So on your calculator, if you're doing it, again, if you second function, press the square root 100. If you see the square root symbol on your calculator, you have to press the button first. If you don't see the square root symbol, you have to put the number in first. So it would be 100 and then press the button. But this one I do the button, then do 100. And I get a 10. So the standard deviation for this particular problem would be 10, and the variance would be 100. Now these numbers came out all even, no decimals, so you might be working with numbers that have decimals, so you just include the decimals. Let's try this one. In a recent survey, 655 working Americans, the average weekly amount spent on lunch was $44.60. All right, so I got $44.60 with the standard, so that's the mean. And this is the sample, so the mean. And the standard deviation again, the symbol for standard deviation for a sample is a S, is 281. So before I even look at the questions, I'm going to figure out all of my numbers on the chart. So I'm going to go 4460 plus 281, that's one standard deviation, 4460 minus 281, then we're going to go 4460 plus twice, and then 4460 minus twice. Finally, 4460 plus 3 times the standard deviation, 4460 minus 3 times the standard deviation. All right, so 4460 plus 281, so 4460 plus 281, 4741. Then I do 4460 minus 281, I get 4179. All right, now do twice the standard deviation. So 4460 plus 2 times 281, I get 5022. 4460 minus 2 times 281, and I get 3898. And 4460 plus 3 times 281, 5303, and 4460 minus 3 times 281, and forgot the times there, 4460 minus 3 times 281, 3617. All right, so now that I have my numbers, let me quickly sketch this out. So in the middle is 4460. One standard deviation away is 4741. 2 standard deviations away is 5022. And 3 standard deviations away is 5303. On the other side, I've got 4179. 2 standard deviations away is 3898. 3 standard deviations away is 3617. So before I even answer the questions, I know that 68%, again, this is empirical rule, 68% are within those 2 numbers, 1 standard deviation away. 2 standard deviations away is 95%, and 3 standard deviations away will be almost all. So it says estimate the percentage of amounts that are between 3617 and 5303. So 5303 is here, 3617 is here. Those are 3 standard deviations away. So that would be almost all, depending upon what they have for a choice, or 99.7. Estimate the percentage of amounts that are between 4179 and 47. That's 1 standard deviation away, so that's automatically 68. Between the 2 numbers, between what 2 values will approximately 95% of the amounts be? So this is asking the question in the opposite way. So here's 95% right here. So this question would have an answer of between 3898 and 5022. That would be 2 standard deviations away. Next one, paying your bills. Let's see, what do we know? The payment was made 32 with a standard deviation of 7 days. The utility company, a large sample. So sample again, the mean is 32, standard deviation is 7 days. Assume the data to be approximately bell-shaped. All right, so let's figure out our numbers. 32 is in the middle. This is going to be 32 plus 7. This is going to be 32 plus 14. Again, twice the standard deviation. This is 3 times the standard deviation, so 32 plus 21. 1 standard deviation is a subtract. 2 standard deviations minus 14. And finally, 32 minus 21. So I just need to figure out those numbers and put them in, and it will make my answering the questions a lot easier. So 32 plus 7 is 39. Then I add 14. 32 plus 14 is 46. And then I add 32 plus 21 is 53. Then I do the subtraction problems. 32 minus 7 is 25. I subtract 32 minus 14 and I get 18. And 32 minus 21, I get 11. So those are all my numbers. So this is 1 standard deviation away, 2 standard deviations away, 3 standard deviations away. So between what two values will approximately 68%? Well, 68% is always 1 standard deviation. So this answer would be between 25 and 39. Estimate the percentage of customer accounts whose numbers are between 18 and 46. Well, 18 and 46 is here. That was 2 standard deviations away. So 2 standard deviations away is automatically 95%. Estimate the percentage of customers with the numbers are between 11 and 53. So here's 11, here's 53. So again, it's almost all or 99.7. So it makes it a lot easier if you get your picture drawn with all the numbers in place before you go and answer the questions. Let's try another one. The temperature in a certain location was recorded each day for 2 months. The mean temperature was 62.4 with a standard deviation 3.1. What can you determine about the data using Chebychev's inequality with k equal to 2? All right, so the mean is 62.4, standard deviation is 3.1. So I know when k is a 2, I'm at 75% of the data. So what can you determine about the data? So I want to, this is 2 standard deviations away, so I can do 62.4 plus 2 standard deviations away and 62.4 minus 2 standard deviations away. So on my calculator, I do there it is. 62.4 plus twice 3.1, so I get 68.6, and then I do the subtraction, so 62.4 minus 2 times 3.1, that gives me 56.2. So I can say that 75% of the data is between 68.6 and 56.2, or 56.2 and 68.6. If k was a 3, I'm going to be at 89%. Again, these numbers are standard, the 75 and 89. But all I need to do is get the two values. So I would do 62.4 plus 3 standard deviations away, and 62.4 minus 3 standard deviations away. So it would be 62.4 plus 3 times 3.1. Oops, let me do that again. 62.4 plus 3 times 3.1. So that's 71.7 on that one. And then the next one, 62.4 minus 3 times 3.1 is 53.1. So I would say that 89% of the data is between 53.1 and